Welcome to Plugin Jamaica's first hosting event. We're going to have a EV repair conversation. Um, our guest speaker today is Kevin Daly. He's based in Bermuda, and I'll let him tell you about himself. Go ahead,
Good,
Kevin.
good morning, everyone. I'm Kevin Daly, based in Bermuda, originally from Jamaica. Half of my career in Jamaica as a mechanic technician and other half in Bermuda. Original petrol head and now EV greatest level.
All right, so we're going to start off with a video that he has done in terms of repairing um, a 2024 Mini Cooper EV. We're going to go through some of the videos are very long, so there will be links to his videos as well as his channel called Tech Dailies, and
Daily.
from there you can watch the full video. But we will be going through a couple of the videos, different points, so he can give us his insight as to how he went about repairing this damaged EV that he got in his shop.
Not getting any sound.
You're not getting any sound from the video itself?
No, not hearing anything on my end.
No, I'm just doing disassemble some hoses and wires in the back. This nothing to do with the high volt system, but it's really complicated around here. So with this type of pump,
All right, so Kevin, in this section of the video, give us an explanation of what you was doing in terms of breaking down, because here it looks like you're trying to take out the entire block of the engine.
yeah, so go ahead.
Yeah, the block motor itself. So give me a rundown.
Yeah, so thanks again for inviting me to this forum. And before I answer the question, I always like to make a note that everybody understand working on EV, it's can be very risky and dangerous because you're working with a lot of high voltage, which mean you can be electrocuted. So safety always have to be a priority. And throughout the video, you will see sometime I have on the block rubber gloves, just a regular latex gloves. And next time you will see me have on the EV protective gloves, both the leather gloves and the rubber gloves. And those gloves generally from 800 volts up, depending on which type of EV you're working on. So we just want to cover that section because I know, person always want to try the do their repair or experiment with the EV, but it's can be dangerous, so you have to follow the safety procedure and be very careful. So before I get into the repair of this EV, one of the first thing I have to do is make it safe to be repaired. And approaching the safety of this EV is different from your normal EV because this one is in an accident. So when an EV in a heavy accident like this, you can have current leakage, high volt leakage, which is deadly. So even just shutting down the high volt system, you have to take great precaution because this car in an accident, you don't know if any wires cut, if any voltage leaking into the chassis. So that was my great main concern before I get into this repair. So I eventually shut down the system And you know, most EV you gotta put a lock on the main safety, the main high volt shut off, just for yourself, not accidentally turn it back on or somebody else turn the vehicle back on when you're not there. So no said that, get out the way. Let's get into the hoses now. In this section of the video, I'm doing all the preparation to take the electric engine out, the electric engine assembly. And if you look in here, you barely can put your finger anywhere. So I'm trying to make room just to get to some bolts and nut. But if you could just, yeah, right there, stop the video right there. I taken out these hoses, and one of the issue I find here that have me a little bit concerned is that even though I drain the coolant out the system, there's always coolant left over in hoses or pipes. And at the same time, there's some main high volt wires running from the battery, running to the AC compressor, to the heat exchanger, and so on. And I'm working right above that, and I'm working, and let's say I'm worried that the coolant leak and then I have a high volt short. And even though the battery shut down, sometimes the EV, it still have current stored in different things. So that was my concern here. So I have to take these hoses out, but also be careful when taking out these hoses. Here I'm just demonstrate how tight it is around there that my finger can, you can't even get a spanner down in there.
All right. I will move along in it, and you can give
Yes.
us a rundown. So here you're having some problems, basically disconnecting the hose.
Yes. Yes, you can pause it there.
All right.
So at this stage of the repair, I run into another problem, which the way the AC system is set up below the cooling system. Now, my concern is for coolant not to go inside the AC system. So with the hoses dripping and the AC system below, I have to take a precaution by blocking the AC inlets that are open. Go ahead.
So right here, what were you doing?
Right there, I'm just making up a temporary block to plug the AC, or any pipes or hose or section of the AC that is open that, coolant or dirt can fall into it. So I'm plugging the one of the main high pressure AC line and the low pressure AC line.
Okay. So if you want to see a full breakdown, the video is on him channel. You can go to him channel itself, and then you will see in more details clearly what I'm doing. We're going to just give you an overview of most of what was being done by him, and then we can keep going through the different sections at key points for anything specific.
Stop right there.
Right, so?
Yeah. Yes. No, go back a little bit. Some more. Yeah, right there.
Sorry.
Yeah, stop there. Keep going. Yeah, this is okay. If you look a little bit over on the right side of the video, you see those orange wires? Those are actually the high volt battery wire coming from the battery pack itself. So that's where I'm telling you I have the concern. Now that I pull the hoses out, you can get a clear view of it. So those was my main concern in terms of the high volt and the coolant leaking. It can move ahead in the video.
All right. So here he was making reference to the high voltage.
Yes,
This was the hose that he was removing.
yes.
All right.
And one of the issue here is that with these clamps, the clamps like they turn the clamps in a way where it's almost impossible for you to pull the clamps off, open the clamps. And that's what I was pointing out here.
Okay. And then now you went underneath the car to pull off.
That's the AC compressor. But if you pause the video here, you can see that yellow wire again. So unlike your traditional ICE vehicle, this AC compressor of high volt going to the compressor, to the actual compressor. So now this make it, you have to be very careful. But if you notice at this point, I have the rubber glove on because one of the challenges while the EV, while the leather gloves and the high volt glove protect you from the high voltage leak or electric shocks, it also have a downside where you can't function properly to hold the bolts and nut and operate the tool, especially in small areas. So if you notice here, before I have the high volt gloves on to pull the high tension wire off, but now I'm back on with the leather gloves once I neutralize this part and make it safe to operate with just the regular latex gloves.
All right. Now here you took off the front and you gain access to all of the mounts. So what is the process here?
The process here is I want to take out the engine and I want to take it out complete. But because the car in an accident, the chassis is actually bent and pushed right up against the engine. So I need to take off more parts from the body than normal just to make some clearance to take the engine out.
And then I see you put on thicker gloves here.
Yes. So pause it right there. So there again, you see, I'm actually holding the high volt wires there. And this where I constantly have to switch in between gloves. So this is a perfect example. Like this particular part, I want to angle it with the protective glove for the entire process. Because it not just use high volt, it also store high volt inside of it. So you turn the breaker off, but still in the back of your head, you just want that second layer of protection by not taking any risk with a part that still store high volts in it.
All right. So in this section of the video, it looked like you was having a problem releasing the mount to actually take out everything, to take out the motor itself. What was going on here?
Yeah, right here, I have a problem with the disconnecting the high tension wires. because as I said, the engine, the front of the car is pushed over. So the connectors are closer to the chassis than normal. And that giving me some problem. And I also having some problem with this mount right there. Pause the video. So I wish I did have a pointer, could point it out. But if you look closer to my end, you see that bracket that going up above in front of the high volt wire, right? That's the actual engine mount, but it's pushed way out of position because the whole front of the car has swing over to the right. So it was giving me a lot of trouble to get that mount out. But at the same time, I couldn't see the entirety of the cable to know if it have any cut or crimp or everything pushed right up. So I was very concerned working in this area there. But once I could verify that the cable was okay and there's no volts right there, then I put my gloves on again and back it out.
So in every step, you was basically making sure that you're able to disconnect before you try to lift out the whole thing.
Yes, so right there, I want to make sure that the entire engine is free, because the last thing you want to do is like lift the motor up, and when you lift the motor up, there's a small wire or hose hidden somewhere and you rip them apart.
And right here, so you was successful in loosening it.
Yes. So right here, you notice how the motor shake?
Yes.
So it's just a good feeling there as a mechanic. Anytime you see the engine give you that free movement, you know you're on the way of getting it out.
So here's a successful takeout. No. So this is your high voltage cable that was connected directly into the motor itself, right? What is this large silver piece right here, so where the two plugs are, right? So
Well, that's the onboard charger there. And then you have it go to the controller, the motor controller at the top.
okay. So everything
Yeah.
right here says a one piece thing that you
No,
took out.
they separate.
Okay.
But like the top one, you have the motor controller, and then you also have a AME, or what you would call in a petrol engine, a ECU, also connected up in that unit in the top.
To the average person, all I see is nothing but holes and everything. So no, you took out the piece that is right here. So this silver piece that is
Yes,
holding everything,
yes.
that is the entire motor mount for everything. Is that correct?
Well, this is a unique design. I noticed on you guys' channel, you guys do a lot of Nissan. The Nissan is set up different from this. What this is, and this just based on my observation. I think they're very concerned if this car meeting an accident. They want a strong protection around that high volt system, the motor. So while this is a bracket holding everything together, it's so heavy and it builds so strong that it can take a huge impact before it collapses. And here I'm just giving a complete view of the electric motor, because for myself, it's new. I never do one of this mini before. So as I showing you guys, I'm just fooling myself also with, the design and how everything just put together and lay out.
Okay.
Can I ask a question here? Have you worked on other EVs other than Mini?
Yes.
What I noticed with this, and tell me if I'm wrong, this look a bit complicated. And I noticed that when manufacturers convert a existing car to electric,
Yes.
as opposed to a purpose-built car from scratch, it's much simpler, the purpose-built car. But it seems like when they convert an existing car, it's a lot more like a non-sweat to me. I don't know.
Well, you're partially right, but one other thing with this car here, it's like it's the philosophy of different say Asia against Europe or America. The philosophy in building vehicle. So Asia more of a focus on cost effective and still make it reliable but cost effective. Europe kind of have a different approach of making it strong but cost effective. So I think that's what at play here. They want to make this package strong because here you're talking about 400 volt, 300 volt. In some vehicle, it might be 500 volts in this unit right here. So if you're going down the road and you have an accident, you don't just want that voltage to everything just crumble. Like a petrol engine, a vehicle hit and the engine will push back and broken up and so on. With this here, you're going to have live current. So you want it to be so strong where it don't fail easily. So I think that's what's going on with this design. And yes, it's complicated, very complicated. To work on this engineer, your head have to be screwed on.
Yeah, I noticed that there's no room for a frunk, and that's another disadvantage with purpose-built EVs. For example, Tesla, one of the safest cars,
Mm-hmm.
and they
Can
have
you
a lot
stop
of
the
room.
video here? Yeah, go ahead with your comments, sir.
Yeah, I was saying another advantage with purpose-built EVs is that this don't give any room for a frunk because they're converting existing cars to EV. But like Tesla and others, well, Nissan do the same thing too. So, but I noticed that when you build from scratch, you have that ability where you can put things different places and make room for other things. But the purpose is, well, anyway, it's a very interesting video. I've never seen a mini powertrain before, but I'm just taking it in. I'm gonna check out your videos too to get some more, cause you might have more details there, right?
Yes, definitely, definitely. And you're correct. The purpose built EV is generally built with a lot more direction for a EV than converting an EV. And I think the main difference with them is not so much the spacing and so on. A purpose built EV, they generally have weight in mind because more weight means less range because you're pulling more weight. So a purposeful EV tend to be much lighter in overall weight, and that help make better range. While when you take a EV will have all the bells and whistles for a normal vehicle and just drop a motor in it, then you have a huge disadvantage of range and room for repair it too.
So
Okay,
good morning.
right here, I did tell you to stop the video because right here is an important part of the repair where the chassis actually, you could physically see where it bent and swing like, say, about a 6 inches movement going over to the right side of the vehicle. So I just want to point out that.
Okay.
So, good morning. My name is Kirk Abbott. I was late to the call, so I hope I didn't miss anything important. I don't know the protocol of the call if you're taking questions at the end or taking questions as you go along. But let me know and I'll behave appropriately.
It's basically questions as we go along, as it's an informal conversation in relation to the repair.
Okay.
So if we reach a section that you have a question, you're open to ask your questions.
Okay. The other question is, how long is this book for in terms of time?
The window for this meeting is about 2 hours.
Okay, so I can't stay that long. I have a little homework to do. But again, by introduction, Mr. Daly, I'm Kirk Abbott from
Yes,
Cattle Energy Limited.
yes,
Um,
good to meet you.
we're a solar EPC. We own a Toyota Pro-Ace.
Yes,
We have just installed 60 kilowatts worth of solar PV canopy on the front lawn of our headquarters. We intend to use it as a generation station and a EV distribution station is the language we're using, which is a charging station, for want of a better word.
yes,
We believe in what we call a PVES economy, which is solar PV, EVs, and energy storage. I think I'm a fairly active participant on the EV Jamaica group. I've learned a lot and continue to learn. And I have a project for you. So I don't know if the host here can share my contact information with you at the end or vice versa. Um,
yes,
I'm interested in a BEV range extender, which is instead of putting a gasoline engine in the back of my Prius, I'd like to put compatible 30 kilowatt hours worth of storage, which will allow me to drive comfortably to Negril and at least back to Montego Bay,
okay.
which I can't do now. So again, with that, it's been a pleasure meeting you, sir. I'll listen as long as I can, but I have some homework to do, and I'm going to ask Howard who to share some contact information.
Sure. And where you tell me your final destination where you want it to go, but what's your starting point?
Kingston. So we can make it in the
Kingston.
grill. But the difficulty is if you're at Negril at 6 o'clock in the evening, you have 30 miles left in the tank. It's a 75
Yes,
kilowatt hour. Theoretical range 200. We only get 181 maximum. And it's 6 o'clock in the evening. You make it to Montego Bay and the charging station is not working. Things get ugly.
yes,
Right? Because the next one is Draxhall or probably somewhere in between. So
yes,
the mental model that we're creating is that we have a battery pack, which, with a little effort, we can throw into the back of the bus, give up a little bit of cabin space, but we have
yes,
30 kilowatt hours on board that will get us safely and comfortably to our next, halfway back.
yes.
But that's it. It's a simple ask, but it requires understanding the innards of what's a compatible module for the vehicle that we're using, which is the Toyota Prius. And once we figure that out, then we think this could be something useful to other folks. So again, we're engineers at the core. So making stuff, building stuff, breaking stuff is par for the course, and we're looking for like-minded people who can give us some guidance.
So the main thing you want is to extend the range.
Yes, sir.
Okay. So
I'm
I'll
willing to, around town, I'll take it out. I'll put it in the yard, right?
okay.
I right run the house off of it. But come if I
Yes.
need to go to the grill, I want to be able to put it in the back of the bus and say, go forth and do your job and come back safely.
And what year Tony is pro?
This is a Prius 2022. Brought it out of the
Sorry.
UK. It's a right-hand drive. It's
Okay.
considered an Icon medium trim, but I can get very little details on the technical specifications of it other than what I just gave to you.
Okay, and you say it's a US model.
No, a UK model.
UK.
UK, okay.
A 2022 Icon Medium Toyota Pro Ace. 75 kilowatt hour battery pack.
Mhm.
Okay.
Sorry to
All
have
right.
hijacked the
I'll
show.
definitely take your information and we'll link up and, talk more about it.
Okay, thank you, sir. Again, pleasure
Okay,
meeting you.
thanks. Good meeting you too.
All right, so now in this section of the video, we're looking at the entire frame itself.
Yes.
To the left side, well, to the right side on the screen, you will see that there's a buckle in the frame going to the
Yes.
spot that you had pointed out. Um, at this point itself, what was the process that you were going through to go forward with the repairs on this car?
Well, at this point, we come into the repair with one idea, and at this point, we actually shift the idea. So first, we was planning that the chassis leg on the left side will need to be changed, and we'll take off the whole wheel arch and fender section there and put in a new chassis leg. But once we put the machine and put the car on the machine, we start to pull it because before you can change those parts, we have to get it back in its normal shape before we can cut anything out. But once we start to pull it back into position, we realize that the chassis leg didn't really need to change. So it shifts the whole dynamic of how we do the repair from this point forward. Because this bumper at the front is so strong. I think this bumper may weigh about 400 pounds or three something. It's very heavy and solid. So I think it actually absorbed the impact of the accident and it literally moved the car over without bending. And because of that, it allows us to move it back over with the same bumper into position, and we didn't have to change the chassis leg.
Okay. So
Yes,
now,
and this is after we repair the chassis. I want to believe.
okay. So I can move on to part 5. No, hold on. Yeah. No, man. Part 3. Sorry. So in the part 3 here, you put it on a work desk and you was taking it apart.
Yes.
Specifically, what's the thought process going through here, taking off all of the holes? What were you attempting to do at this point?
All right. At this point, the plumbing work for the cooling system captured my imagination. And I said to myself, old time car for this car, half of them I was here throw it. But looking at this thing here, you realize there's a method to the madness. And I keep asking myself, couldn't they make it more simpler, man? It's just hoses up on top of hoses up on top of hoses. And as an experienced mechanic would know, every single one of these hoses have to go back in the correct place. And that was my main aim here, is to open it in such a way where I can't make an error with the hose when I going back the other way, when I reinstalling them. And at the same time, I want to finally get rid of all of the coolant. Because even these hoses, while I'm taking them off, fill with coolant. So I want to get rid of all of that coolant and liquid before I actually start touch the electric parts then.
And then for me now, here's in the video, over to the left side, I see a set of tools.
Yes.
You can tell me about those tools?
Yes, those are special EV tools to work in the high volt system. And it's basically a regular spanner and socket with high voltage protection over them. So with those tools, you generally need them to work in the high volt system. But one of the issues I run into with these tools is that the manufacturer and the people who making the tool, and we have to back up a little bit, EV is still in its infancy stage compared to the petrol engine, where for many years now they have a chance to redesign and refine both tools and the vehicle. With the EV, the tools them not refined that well yet. Over time they will get better, but at the moment they are a bit bulky, thick, and the concept with the person who making the tool is not lining up with the concept of the people who making the ICE engine. So I have to still use some of the normal tool, even though it's risky. But I make sure I have on my rubber gloves and protective gloves. Stop right there. Sorry, go back just a little bit. But yeah, right there. Okay. You notice right in front of the engine, you see those socket sets.
Yes.
Yes. So those socket sets I have to use to actually dismantle some section of the EV engine, because even though I have the right EV tools, they just couldn't fit certain area, or it just didn't give you that, what would say, that grip we want. We don't want a half grip when we're pulling on, we want a full grip. So that's why this is a perfect example of me after relying on the normal tool, even though I have the EV tools.
But then in that instance, you've just given credibility that a regular mechanic can work with regular tools on an EV, but there must be safety precautions that must be in place for them to work with these tools. So, from your point of view, what is the best advice you would give to a regular mechanic using tools? What are the core, what would you consider a core importance for a regular mechanic using regular tools on an EV?
Well, one of the core thing is, yes, you can use regular tool. It's not recommended, but you can use it with proper safety way. And the main thing is, don't allow your body to be a pathway to negative or earth. And that's a core principle of electric, especially high volt electric. So that's why you have to wear your safety shoes. That's why you want to have on your safety gloves, because those are good protection against the high volt. So for the regular mechanic, yes, you can use regular tools in some area. Also, you want to make sure the EV is powered down correctly, not just power down. There's two difference. You can you can turn off the high volt battery, but that don't mean the EV was powered down properly. So power down mean you have to log into the system and power it down properly, and that way it start to cut the voltage in all the important places for you to work on the EV properly.
Okay.
So in the case of no power in an accident, how you approach that procedure? Because sometimes a car will be in an accident and the emergency response team will cut what they need to cut and shut down the power even before it get to you. What do you say about that?
Yeah, well, an accident EV is different from a regular vehicle. So even with the so let's say the first responder, they can't just cut in an EV because they themselves will become a part of the problem. So I believe most of the first responder, they have some sort of EV training now, how to power down the vehicle. And the vehicle have to power down, especially if it's in an accident. If it just driving along and break down on the road, that's different. You know, a flatbed truck can just lift it up. The next thing now with the EV is that some EVs front wheel drive, some EVs rear wheel drive. So what happens when you go to an EV that is a rear wheel drive, but the front is all smashed up and you can't pick it up from the front? So that's when, you know, you have to have a experienced tow person who actually know how to put the EV into towing mode. And towing mode is basically it neutralizes up the motor and the transmission, so the vehicle can be towed. And it also power down the vehicle.
Alan, I see you raise your hand. Ask your question.
No
Okay.
voice.
Yes, I was muted. I got into the meeting late because I was scheduling for 10 o'clock. So I didn't I'm seeing where this appears to be a accident damaged vehicle.
Yes.
Right? Question, did the airbag deploy?
Yes.
Okay, because from my understanding, from what I know about EVs, is that anytime the airbag deploys, it also automatically disconnects the high voltage battery.
Not really.
Because some of them are designed like that.
Depend on the manufacturer, yes. Because I actually pick up one BMW once, a i3, and the front was totally crushed, pushed in, and the airbags them are deployed, but the vehicle was fully powered up.
Okay.
It actually, I have to power it down when I went there.
Okay. Okay. Thanks.
Kevin, where are you based? You're based in Bermuda, Jamaica, right?
Yes, Bermuda. Bermuda, but back and forth to Jamaica.
So you work for yourself or you work with a company in Bermuda?
Yes, I manage a company and work for myself. And we also have a company in Jamaica too.
Oh, you're familiar with Bermuda Motors? You're having an affiliation with
Yes.
them?
Yes, I'm familiar with Bermuda Motor. They are a dealer for some manufacturer.
So your company is separate from them?
Yes.
Okay.
Actually, this mini here come from Bermuda Motor. They bring it there first. And basically, the lady was told it was a write-off, can't fix.
Okay.
And they bring it to us and we say, no, it can be fixed and we repair it.
Yeah,
And
we
we do quite a few EVs like that too. Because I tell you one of what I find going on with the EV. It's not a lot of EV technicians. And the few technicians is a very small percentage want to go too deep into the EV. So when you're talking about go strip down an EV complete, even the average EV technician reluctant. So they quickly will give the customer some misguided information. The car can't fix it beyond repair when that's not really accurate.
So we're in Jamaica. What I want to ask is, a couple of questions. Where in Jamaica your company is, and you must have a team because you're just one man. So and you're in Bermuda too. So how would that work? You have a team. Are you only available when you come to Jamaica? How would that work?
Well, if you give me a contact offline, then we can talk more. But some technical detail I'd prefer not to go into in the live chat.
All right, we'll exchange some contacts. Just to get a little background. I used to work at Birmingham Motors too.
Yes,
Um, now I'm working. I used to work at Tesla. Not working at Tesla anymore, but I'm working at a certified Tesla shop where I'm the Tesla technician there. But I'm more on the bodywork side. So there's
yes.
some
And
overlap.
your voice sounds familiar too.
Yeah. They might know each other. I don't know. We'll see how it go when we link
Yeah,
up. But with there's some overlap with the technician service side, like what you're in now. So
yes,
this kind of enlightening me, especially with other EVs because I'm more only used to Teslas.
yes. Well, first of all, I'm old school mechanic where, you have dealership mechanic and you have the traditional mechanic will fix anything. So I have the similar approach to EV, where we want to learn and gain knowledge how to fix any EV. So that's one of what going on here with this repair. We're working on Mini next time, we're working on a Jeep, next time we're doing a Nissan. So yeah, that's one of what we want to accomplish with this repair.
So based on the question that gentleman asked earlier, you
Mm-hmm.
look like you're capable of going into the conversion business student. Like
Yes, definitely.
yeah,
Definitely. We
you
can,
think
I can build the battery pack, wire out the whole thing, install all the different sections to turn a petrol vehicle into a EV.
yeah, I'm kind of interested in that too. That's why I want to link up with you as well. And
Yeah, so
and a lot of leaves
go ahead, go ahead.
around. And a lot of Nissan leaves around. They are good cars, but the weak point on them is the batteries. And there you can do a lot of improvement on those batteries. But the problem is the cost. If you can do it cost effectively, that would be a winner.
Well, as the gentleman asked earlier with the Toyota Proace, and one of the things that come to my mind was building us. How could we add to the existing battery in a cost-effective way to extend its range? And it's basically the same thing you're saying here. So, as a person who can build the battery, install the satellites and different things, it ring my curiosity. How can I make both of them tie in together and work as one battery pack? Because sometimes you look at a traditional vehicle that or even an EV vehicle, and depend on your purpose why you have that vehicle. There's room in that vehicle where you could extend by putting a extra set of batteries and so on. Because that era of the vehicle, you might not be somebody who needed to go supermarket. You might need it to go from point A to point B, and you want to put more battery in it.
I have a very big ambition here where and I probably can talk to you more about it in details. In Jamaica, I'm building, and I noticed that transportation costs is a lot for delivery. So I decided to buy a dump truck. So I bring in a dump truck from Japan. I Isuzu Canter, but it's a diesel and you have the DPF situation to deal with, and it's also another situation where it build up some stuff in the exhaust, and if you drive it too slow, it build up and you have to stop and burn it off, all kind of problem. I have ambition to turn that truck into a EV. Now we're talking about cars here. What's your view on like a 3-ton truck?
Well,
I don't know if we're steering off topic here, but since you're here,
no, it's still an EV topic. We can talk about it. It's no big deal. Me and a few guys actually look into that.
lovely.
And some guys from Cuba, some guys from the US. And we actually look into the heavy equipment. We also look into tractors, farm tractors, because a lot of guys who own farms was saying fuel and maintaining the tractor is one of the biggest operating costs. And they was looking, we was looking into how we could make some of the tractors into electric. So yes, it's a good conversation. We can discuss it in more depth in another program, being that we're just focusing on the repair of this EV today.
That's a very good recommendation, because a conversion, a EV conversion was actually done a while back in Jamaica. So having a conversation about that, we can do that. We definitely can do that. We can probably do it for the next. We can probably do it for the next conversation session.
Yes.
Yeah, and it would be nice in the meantime, Kevin, if you could have a project done. I don't know.
Well, well,
I could invite the guy who did it in Jamaica to be on the thing. So it's good to see hands on as we discuss.
well, for me, it's baby step. I want to go step by step. I have all the technical know-how, how to do all the calculation and change the vehicle from petrol to electric. But you also need equipments and tools for that process. And the first step for me in the EV is to wrap my head around repairing the EV. That's where I kind of focus on now. But then I'm going to expand into the conversion. Where I locate in Bermuda, the conversion is not a high demand for the conversion, because the EV price range and the petrol vehicle is not such a great difference like long before. They're very close in price range, so the average person want an EV can buy an EV at a reasonable price here in Bermuda. Jamaica now, I think where guys of extra vehicle or a classic, I think there's a bigger market and better potential there.
Even in commercial too, like myself. It will be
Yes, in the commercial too. Yes, both commercial and private owned vehicle and so on.
Alan, I see you raise your hand. Go ahead again.
Yeah. In terms of the 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 Toyota Pro Ace that Kirk talked about earlier, I am very interested in that vehicle, and I'm actively trying to get one as we speak. Sort of in negotiations. One location has it, price is good, but having problems shipping it. None of the shipping lines want to carry it from that destination, from that source. But in desperation, more or less, I also looked on Copart in the UK, where Kirk didn't get his from Copart, but I looked at Copart in the UK, and I see a number of this vehicle. This vehicle comes with 5 different badges on it, 5 different brands. It's made in Italy. It's actually made by Stellantis. It comes as a Citroen, a Fiat, a Peugeot, Vauxhall, or Opel, as well as a Toyota. And it's identical. All of them are basically identical. But I've seen on Copart where they have one with slight damage, what appears to be slight damage to the bumper. And the description says it doesn't run. So it does not run. I can't understand how a vehicle like that with actual damage to the bumper cannot run. My only theory is that in the accident, whatever sensors triggered the disconnect for the battery and it can't run. Would that be a feasible sort of reason?
Yeah, yeah. The answer is a two-part answer to your question. The first thing is the shipping. You should be able to get it shipped. Electric vehicle will fall under safety hazard where it needs special shipping arrangement. So you might can't ship it rural, but there's tons of shipping company where as long as it's shipped under the proper protocol, which is, let's say, twice the price of the rural shipping, you shouldn't have an issue to have it shipped. And this way Stephen can even go in, our fellow EV guy, Stephen, he can give more detail than that on that. But based on my knowledge, you shouldn't have an issue with that. In terms of the vehicle not running, it could be something simple because depend on where the accident happened. It's just like, say, your petrol vehicle, where in the front bumper you have a fuel pump shut off. So once the vehicle get a hit in that area, when shut the fuel down, make the engine can't run, gas can't leak, etc. The same way some EV have that safety feature where it shut the vehicle down if it get impact a certain place. And sometimes it just need a reset, a recalibration and adaptation to get it going again.
Well, I noticed at Copart, there were a couple of the vans there that had airbags deployed, and I think one of them said still run and drive. But another one had a actual warning on the dashboard saying traction system failure, check your user manual or something like that. But I guess what confuses me is that in the UK you would think that they would have people there who know how to rectify these things. And the vehicle would end up on Copart with a description saying don't run.
No.
My answer to that, and we want to get back to the repair because we have limited time, right? But let me answer this question here. It's not necessary they sell it and it can't fix. First of all, I would encourage you to say, if you want to buy that vehicle, pay the extra fee and just hire a company an EV company technician to go check it for you. That shouldn't cost a lot. It's just like if you're buying any other vehicle and you can look at a photo and the vehicle just look like a small damage on the door or the fender, but if you get somebody go check it, them tell you so the chassis bent. So just pay a EV technician. You can, pay them a small fee and tell them you want to get this vehicle here inspected before you purchase it. If the seller don't want you to do that, then you stay away from that vehicle.
Right.
They shouldn't have an issue with a technician come and check it.
Right. Okay.
Yeah. And let's say that vehicle selling for, just say £5,000, just an example, and you might have to pay a EV technician £300 to go check it. It worth it worth take that chance with that £300, yeah.
Right, right.
All right. So back into the video itself. Here you started to you started to dismantle the unit itself, even with the cage itself on. I take it the unit in question that you have in your hand that you're pulling off now is the controller for the
Yes,
car.
yes.
Mm.
And it's I would call it a controller assemble,
Okay.
because there's quite a few things built into one.
Okay. Um, so you removed the controller assembly, but you left the motor and the rig intact. What's the thought process here?
Well, I go in step by step but careful, because this engine is not like, we have 30 years experience disassembling and reassembling a petrol engine. It's the first time I'm doing one of this particular engine. So that was the thought process here. Just don't go too fast and disconnect too much stuff one time. Take proper notes and observation while you're taking it apart.
So here in this section, I see that you have on a the heavy red gloves and for safety.
Yes.
Mm.
And I wear the heavy red glove, but it wasn't 100% the safety protocol, because really anytime you have on the red gloves, you need the leather gloves over it, because the red glove is easy to puncture,
Okay.
and the leather glove is what protect that red gloves. But the leather gloves, again, it's so bulky, you can't hold certain nut with it and bolt.
Okay.
So I have to, even though I want a little bit more protection angling that unit rather than just the regular latex gloves.
Okay. So here in this section, you're going for the motor itself. Is that correct?
Yes, the motor and the transmission.
Um, then my question would be, why were you trying to pull the motor on the transmission at this point?
Well, first I still have to get that metal cage or bar off the unit. And the main reason why I need to get to it, because the motor itself stopped work from the accident. And I could see some areas damaged. So I wanted to pull it apart to find out why it stopped work. And do we need to, I didn't just want to just change the motor. I want to go about it a traditional way. Let's open it up and let's see what's wrong inside of it. And maybe we can fix it or change the pieces.
Okay. So here I see that you started to remove the actual metal frame mount from the
Yes,
motor. So based on the design of the Mini, the mounting frame itself was basically like one giant piece holding everything together. And you figured out to take the mount, you figured it out right there, basically to take
yes,
it off,
yes. It's different from your Nissan Leaf.
right?
If you
Um,
drop out the Nissan Leaf electric engine,
mhm.
then you don't have that safety or mounting. Everything is just one compact unit, relying on themselves as a overall structure. So with this here though, I like the design, because stop the video here. this is why I like the design. Compare with the Nissan Leaf. You notice this black material, it's wrapped around the motor
This one.
and the transmission, right?
Mm-hmm.
Yes, it's a heat resistant material. And if you look, there's a distance between the controller, the charger, the motor, and the transmission. And for me, coming back from the days, let's say Volkswagen Beetle, which was an air cooled engine. I think them have some. I'm not in their design room, but just unpacking all the engine design. I think there's an element of air cooling going on here. One, the aluminum is a heat sinking material. Traditionally, it absorbs heat. So they make it strong, they make it big, but it also absorbing heat from the motor, as well as the liquid cooling the motor. But also you have an airflow going on around the motor and the transmission. So I think the cage served that purpose of isolating different components of the engine so they can be also air cooled and ventilate properly. Unlike, say, the Nissan Leaf, where everything compact. So you're not going to find that air circulation between the different units because everything just join up and squash into one.
Okay. Okay. So here you was taking off the mounts and you gain access directly to the motor and the gear. Is that take it? That's the gearbox, is that correct? Right?
Yes, the transmission, yes.
Transmission, all right. Right. So uh,
So stop right here. You notice once the frame off,
mhm.
you're looking at basically at an independent unit by itself. That's what captured my mind here. All of a sudden it just creep upon me that, this section here, they just isolate it by itself. Why? Because they want a proper airflow going around it to help with the cooling, not just relying on the radiator.
Okay. So in comparison to, let's say, in comparison to a regular engine, was it to get to the motor itself versus that of a regular engine? Was it difficult in comparison?
Much, much more difficult.
Okay. And this was just based on the manufacturer that you was working with at the time then?
Yes.
All right, cool. So now, hold up, I'm trying to see where you took it off. You took off the transmission here, and you had the motor piece, and you still had a bracket to take off.
Yes. This basically, I was just more trying to figure out this section here as I go along.
Okay.
And I realized that it's just mainly like high tension cabling transferring voltage from the controller to the motor, but in a safe way. And at the same time, they wanted to have some form of cooling too.
So I take it here you was draining all the transmission fluid.
Transmission, yes.
Okay.
Actually, it's a kind of gear oil instead of a fluid, yeah.
All right. And now, so my question to you is, what were you looking for when you were trying to take off the transmission itself?
You mean when we're disconnecting the transmission from the electric motor?
Motor, yeah.
Yes, well, right here, I want to make sure it didn't fall apart when I'm taking it off. Sometimes when you're opening an assembly like this, you might find a bearing fall off or some spaces or so on. So that was my concern there, that nothing fall apart while I was opening it.
All right, so you took off the transmission, and then from the picture to your left, I can see that the transmission was like a one-piece reduction gear. Is that correct?
Yes, it's just a one gear ratio.
Right. And what was the process here? All right, so you took off the transmission. The motor itself looks in good condition. The transmission.
Stop right there.
Mhm,
Before keep your thought, let me just mention something here.
mhm.
So you notice all this transmission small is like 75% smaller than a ICE engine, or anybody not familiar with the term, a petrol vehicle transmission, 75% smaller. This means you're saving a lot of weight. That's one. But how could it function and it be so small? Well, one of the things about the electric motor is what allowed this transmission to be so small. With the electric motor, let's say a ICE engine, a petrol engine, when you rev it, and let's say it go 8,000 RPM, and at 8,000 RPM it produce 100 foot-pound of torque. But it didn't produce all that torque at 800 RPM. 1,000 RPM it produced 100, 2,000 RPM it produced another 150, like that. It building up the torque until it reached 8,000 RPM where it produces maximum torque. So 800 RPM meaning how much revolution per minute. So it going 8,000, it making a complete circle in 8,000 RPM in 1 minute, meaning 8,000 revolution in 1 minute. And then it produce the maximum torque. With the electric motor, before it reach one revolution, just the moment it move, it produce maximum torque. So that's what allowed this transmission to be so small. So think about it. The electric motor producing, say, let's say 200 foot-pound of torque, and not less than half of a revolution, it produced that total torque.
So what you're saying then, electric motor doesn't need a transmission that go through a sequence of gears to build
Correct.
up torque. So that again increase the efficiency because you don't have a gearbox problem really.
You don't have no gearbox, you don't have no loss of power. You have less waste energy. So from an EV point of view, those are the technical things I love about EV. Because, if you're building a race engine, you're trying to reduce loss power, get more torque at your wheel and so on. But the electric motor with the transmission setup just get rid of all of that. You have maximum power with less moving parts, less loss of power, and so on. Okay, you can go ahead.
So here you separated them both. You were providing I'm not getting the audio correct, but you were providing information based on the both of them being separated that you just covered. Is that correct?
Yes.
All right, cool. So Let us move on to the next part of what you did here. Let's see. You did the repair. So here in your part 6, you were starting to put everything back together.
Yes.
Right. Hold on, did I miss anything? Hold on. No, man, I missed something. Hold on, sorry.
So part 6, that's where the engine reassemble.
Oh, okay. Then yeah, we're in the right spot then. Hold on. No, hold on. There you go. Sorry. Before you reassemble, you were putting it back together after doing. Here you started putting it back together.
Yes.
And the reverse was much simpler than taking it apart.
Not necessary. Because depend on your definition of simple. Simple can mean it was more challenging to open it, but on the reverse, it can be simple to close it together, but was it closed properly and will it work? So it wasn't simpler because it more mentally difficult, because in the back of your head you're thinking about the process you go through to pull it apart. And if you do, just think about it. Me closing up this transmission and something never done correctly. And you can't find that out until you're ready to test drive the vehicle. And you realize you have to go pull it back down and take off back the transmission. So it make it mentally more difficult, but physically more easier to put it back together.
Kevin, earlier
Yes.
you said the motor wasn't running.
Yes.
You put it back together now. So what did you do to fix it? What was the problem?
I can tell you privately, but I put it this way. I also fix vehicle for a living, so some things we have to like keep in house just to be competitive. But not live, I can tell you more detail.
Okay.
Not necessarily details, but was it a big issue, a small issue? Was it, just general?
Actually, it was more impact issue.
Okay. Impact issue.
Yes.
So
let me just add this. One of the issue with this motor here, when you pull it apart, and not just this motor, electric vehicle, getting the start position for the motor, where it park and where it start, getting that calibration correct is very important, and that was one of the challenging part of this repair in terms of the motor disassemble, everything pull apart, but you have to recalculate it to get it back at the right start position.
Didn't know that. There's some similarities with ice, like top dead center, bottom dead center, stuff like that.
Yes.
So move to 6. So here in 6, you fix the frame, you put him back in the motor and everything else.
Yes.
You still have the safety precautions and measures, wearing the gloves. Basically, since you're not dealing with anything heavy, you started to drop everything back in with regular gloves.
Yes.
Right?
Not necessarily not dealing with anything heavy. At this stage here, I know 100% that the unit have no high voltage there. So I could just function. with the rubber gloves.
And I said that you adapt yourself to the space that you was working with, so you are now more comfortable putting everything back together versus the problems that you were having.
No, what happened here is that at this point, part of the repair,
Mm-hmm.
the all the damages is gone. We fixed all the body damage. So the engine was much easier to maneuver in place and the mounts and so on.
In that shop, I see other vehicles, just strictly electric vehicles you work on there, right?
No, we work on all type of vehicle, electric and petrol. Our majority of our customers are long-time customer with petrol vehicles. EV really start get grounded over the past 4 or 5 years in Bermuda. It's been around a long time, but people really start to buy into it over the past 4 or 5 years. So as a vehicle repair company, we just adjust and start deal with them too.
And you touch on a point. So basically, you were able to adapt to a changing environment, changing technology. Um, Being in Bermuda, do you see other companies moving at that pace, or do you yourself, since you've adapted to the market change, from my point of view, you have the advantage. If you were to say the same thing to a person here in Jamaica, what would be you any advice you would want to give them?
In terms of adapting to the electric vehicle,
Yeah, because we have some mechanic out here, so them not touch it for nothing. But times are changed, so what would be your advice to tell them? Say, yeah, it makes sense to change with the times.
well, one of what I would say is that traditional mechanics. All right, let me back up. If you have 100 mechanic traditionally that fix vehicle, from out that 100 mechanic you would have maybe five is a technician, and is always a reason for that because a technician, you have to master your core subjects, and you have to have meaning maths, English, and science, and so on. And you also have to have a certain flexibility in terms of adaptation to new way of how the product produced. And you find the traditional mechanics from a long time. Him fix the engine, but him not touch the starter motor, him not touch the alternator. So that just magnify on a bigger scale with the traditional mechanic now, where instead you have a small starter motor, you have a big electric motor. So the guys don't want to touch it. So my advice would be for just take it one step at a time. If you're a traditional mechanic and you want to start work on EV, don't just look at it as a mountain where you have to learn every single thing electric. You can just do some basic programming it, and you'll be surprised to know how easy it is to adapt to an EV because of your years of experience fixing vehicle.
So in this, you put back everything. Uh, so we'll cover everything in this one. Hold on. So move to my part that I like, which was 7. 7, yes, I am a computer person, software and everything. So no,
Yes.
to me, you have everything up and running, and then you had to go into the service diagnostics of the car.
Yes.
All right. So here you generated you started looking at the error codes them because you said they were generating errors when you first started to put it back together. You were doing some fault scannings here, right?
Yes.
You had your OBD you had an OBD connected to the car. You were running your diagnostics. So no, based on your point that you just made to
Stop the
before.
video here.
Hmm?
Stop the video there.
Right.
But go ahead. Keep making your point.
So based on your points right before, talking about a traditional mechanic, this right here, so from your video presentation doesn't look complicated, but it seems that when people say electric vehicles are computers on wheels, you indicated you in this video you're showing that the same diagnostics technical skills that a regular mechanic will have can still be applied to an electric vehicle. Is that correct?
Yes. It's correct with an exception. Yes, a regular mechanic, you want to learn about the high volt system. And if you get the high volt system done, then you can adapt to a EV.
Mhm.
Yeah, with in terms of the computers, the electric vehicle is no different from a petrol vehicle in terms of computer. It's the same setup and the same kind of security features. What you do find now is that once the vehicle pull apart and you try to reassemble it, some manufacturer they would require you get a security code for certain steps in the reprogramming. Because them don't want anybody. So it's not like before somebody steal a car and them scrap the car and sell that. No, every part talk to each other. And in order to get them going, you have to get that security code or have the necessary tool to do that bypass. So that's one of the challenge. But right at this part of the video, where I stop you here, is that every technician, or I would say professional persons in their own individual career, you know, you know when you run into trouble, you know when you're back up against the wall. You don't need no outside person to say you're in trouble. So all along, right up to this point, the repair flowing nice. I feel like I'm in control.
Everything ready.
Everything going good. Once we reassemble the vehicle, I'm gonna do this diagnostic here. This is basically a health check. I do a health check on the entire vehicle. And it's normal, you see so many trouble code. You see one system having 15 different trouble code, another one having 8. So all of those orange boxes you see, they have multiple trouble code within each of those boxes. So at that time, I feel like, okay, this is normal. You just need a reset. Everything going to go okay. But when I do the reset, you expect this to be cleared up. But to my surprise, everything come back. At that moment, I know I'm in trouble. How much trouble I'm in, I'm not sure, but I know this is trouble. This is so much trouble code come back. Now my mind going back. Did I fix everything good in the motor? Was everything connected up back properly? Your mind in reverse mode start rewind the whole process. And you question and you answer, you question and you answer. But how you come back with these trouble code? Go ahead.
So here you were explaining the different error codes that you were coming across.
Yes.
You then took it out and then started to run an individual diagnostics of all of the error codes that you were coming across. Is that correct?
Yes.
All right. So you have the ability to do a diagnostics not only inside but also outside of the car, and you had reference material that you found available to you. So let's say a traditional mechanic working on it would be able to access some of this information that you're looking for.
Just a minute. Just a minute. Just go back a little bit with the video. Stop. Yeah, right there. Good. Sorry. Go ahead. Pause it there, so for now.
Right. Right, yourself.
Yes. Sorry to break your thought process, but go ahead. What you were saying.
So a traditional mechanic can do this, will be able to have access to some of the information that you're accessing right now. So run a diagnostics, then go outside of the car to take a look at, find different manuals. They would be able to, the same steps that you're using, a traditional mechanic can do the same thing to show competency in repairing electric vehicles. Is that correct?
Yes, that's correct. And let's say, let's say many years ago, when I'm working university, I may give a good example. The University of the West Indies. Um, at the time, Toyota Jamaica bringing in a car named Toyota Crusader, brand new, nice car. And that car, the lecturer that was driving it, it overheat and he keep driving, the engine messed up. So now this car was just not even a year old when that happened. And they want to send it to Unimoto or Toyota Jamaica, but the big manager come to me and said, Kevin, can you handle that repair? I said, yeah, I can deal with it. So you deal with it, not send it to no Toyota. It was less than a year old. At the time working on that car, latest technology, computer, latest, everything latest Toyota have. At that time, Toyota Crusader is a top car. One of the issue I run into the car that time, I need technical data. It wasn't an issue to pull it apart and reassemble it. The issue was technical data, specification, like that. And it was close to impossible to get it because at the time, there was no Google, no YouTube, no Facebook, no electronic manuals. The only way you can get technical data at the time was through the dealership if you have a brethren can squeeze you some information, which in a them time then nobody no want to share nothing with you. So a long story short, I couldn't find no information for the car and I needed to special order a book and I needed to wait like about 3-4 months before the book arrived. Fast forward now, a traditional mechanic, if you look at my laptop, that's a schematic diagram I'm looking at. And it's a schematic diagram for that many. So I'm working on a car similar, 1 year old, less than 1 year old at the time. And I could get a schematic diagram for it. without going through the dealer or the manufacturer. If you look on my left, that's a diagnostic computer, and I have access to the entire vehicle electronic. So what's my point? The traditional mechanic now is not difficult like what it was before. If a normal mechanic want to make a transition to electric vehicle, it's mind over matter.
Mm-hmm.
All them need is the will.
Mm-hmm.
And that's what lacking. Guys don't have the will inside to go for it. Because if they make the decision to go for it, it's right there waiting. So I hope I answer your question.
You have.
Yeah, just one more thing though. Yeah, I like that insight. But I find Jamaica are very talented, even in an unofficial way. They might not have papers bearing their name. Well, I find a lot of Jamaicans are very talented. Yourself here is a demonstration of that. And I think that as soon as they get a hold of this thing, it will all be off to the races. Like you said, it's just a mind thing, but it's much simpler, a little more technical, a little more unfamiliar, but much more simpler. But you mentioned earlier a stumbling block in the way of getting different codes from the manufacturer of it to get over certain hurdles. I know that Tesla, you can pay for some of their stuff to do their cars.
Yes.
So my question is this: you have to pay all these different manufacturers for their gateway into these roadblocks to run a successful EV business.
Well, it depends on the investment where you want to make. Because, for example, you have a diagnostic tool that will start, say, from 500 US dollar, go up to 10,000, 15,000, 20,000. And then even at 15,000, it's split. Because you have diagnostic tool where you pay 15,000 or 20,000 and you own the data. You have diagnostic tool where you pay 15,000, but you're renting the data. So at the end of the year, it expires. And you need to fork up another $5,000 or a monthly subscription of $1,000 or $500. So you see, it can go real expensive. So this we're selecting the right tool based on what the tool offer, the existing offer of the tool. What is the practical thing them where inside of the tool where you need? Because no one tool cover everything. So that's where you have to really calculate. Should I make a $1,000 investment and buy this tool, or should I buy the $6,000 one, or should I bite my lip and buy the $10,000 one? Then the next thing now with the tools is that with the diagnostic tools that would give you all that data, it's a risky business updating. So sometimes I will buy a tool and don't update it for 2 years, 3 years. Sometimes I never update it because you have cases where the tool would come with certain features and certain codes and certain things. But when you update it, it lose half of that because them dumping stuff to put new stuff. But the stuff that they're dumping, you did pay for it already and you need it. So in that case, for me, sometimes it's easier to keep the tool 5 years and update it and just go buy a new one. So, as I say, it's not like one time. One time is like you can't do nothing without the dealer. Mechanic work is not there. It's not that place anymore. You can get almost any data except very few security features. And then you even have certain tools where can still give those features. The issue is certain brand like say Volkswagen, they would say, okay, you do some work on the charging system and you need to recalibrate it, but before you recalibrate it, you have to get the security code. And that's where the difference is with brand. You know, another dealer, another manufacturer might say, no, you don't need no security code. Go ahead and recalibrate it. So, you know, it's not a simple, straight answer to the question. It's just based on your calculation as a technician, how much you want to invest, how much you can invest, and how you look, what return you're looking for from this investment in this tool.
There's a different kettle of fish now. Before, a man could buy a ratchet set and some spanner and go under a tree or work on a car, but now it's like the tooling it's a little much different these days. A lot more investment it will take, you're saying.
Yeah, but then again, I have this say where everything changed but nothing changed. So in this particular topic about changes, that's where network is important. So networking meaning, let's say a timing tool for a regular petrol vehicle. Before, every manufacturer use a mark. You don't really need no special timing tool. You have a few vehicle like say Volkswagen again, some European vehicle that you may need a special tool. Very few back then. Now, almost every manufacturer telling you to work on this engine, you need to buy this special tool for $1,000, $1,500. And that's for each model, not just for one engine, not for all the engine where they make. That's just for a particular model out of all the vehicle they make. So you can imagine you need a very large tool room to stock so much different timing tool if you're working on multiple vehicle. But that's where the network important, where you have to give and take as a technician. So I have guys who work at the dealer. They call me up, hey Daily, I have a problem, man, with this vehicle. Have you ever come across this? At that point, I have to make a conscious decision to help him and not think about, hey, you work at the expensive dealer, you guys have a lot of money. Why you want me share information with you? Your boss doesn't speak to me. No, I look at the individual, this mechanic, him run into some trouble and he needs some help. Let me help him. My turn going to come where me have to call him up and him working in at the dealer and me just simply need a valve adjustment, or let's say this electric mini, I need to know how much to set the motor start position. But me not have no data upon it. So me have to call up one of my friend, hey, I run in a trouble here, man. I need the setting for the motor start position. Can you help me out? Him now look at me and say, oh, why I help you so and so. So that's what I said, the network. Nothing changed regarding building the network. And you have to be very flexible. And even same way with the tool. Nowadays, you can't buy every single tool because it's literally not possible. You're gonna need a warehouse building. So you know, one guy, he might work on Peugeot, another guy work on Volkswagen. Hey, you have a timing tool for this engine? Yeah, some guys will call me, man, I'm working on a BMW and I need the timing tool for this. It's an expensive tool. All right, look in there. It's good. Everything not broken. If you broke it, then you have to buy it back. But here's the tool. Go ahead.
So yeah. So apart from the network, there is some cost though, as you mentioned earlier. would you say that this make the repairs more expensive than ICE? Would it contribute to the cost of repair? Because you
No,
have much,
no,
no? Okay.
no. It's the same thing, because if you're working on an ICE vehicle, it have the same protocol in terms of electronic and engine management. So notice the word I say, engine management. So it don't matter if it's a ICE engine or a EV. Anything dealing with engine management, it basically have the same protocol. So you still need a expensive tool, or you still need a good tool. And from you have a good tool, it is no difference with the cost. Like, I don't see where a EV scanner costs twice the amount of a ICE scan tool. What different is how you use the tool,
As a
not the
matter of,
cost.
as a matter of fact, with Teslas, there's a lot of things you can do on the screen. You don't even have to need a tool. There are a lot of things you can do on the screen. So
Yes,
good things.
yes.
Howard, I just wanted to raise something here. Howard, were you part of that seminar at UA? Was it last year? Where they're
Yeah.
talking about qualifications. I mean, my big my big issue with that seminar is that a lot of what is needed to work on all modern vehicles, whether it's an internal combustion or an EV, is the data, the information, and the diagnostic tools, which some brands and some dealers want to hold very close to them chest, don't want to give nobody, and makes it difficult for an independent garage like say a Kevin to work on these vehicles. How how do you get to this question is to Kevin now? How do you get around that issue where the dealer is holding on to the information or diagnostic tools very tight?
Well, let me answer your question. As I said before, everything changed, but nothing changed. You have to have that approach. Because traditionally, the dealership, them have a business, and part of their business in how they make money is corner the market and close it out to others. So you is an intruder if you try to get into that space of the market. Nothing changed in terms of the dealership 20 years ago, 30 years ago, and today. It's the same principle they function on. A new technology, block them out. We're not selling you the part, or they want 3 times the price of the part, but you can get it cheaper elsewhere. But if you get it elsewhere, they're not installing it. I actually have a rough discussion with a dealership maybe sometime last year, because this car need a ECU. I ain't going to point out the dealer. This car need a ECU. The ECU is like $1,000. But this ECU need a particular code, security code for you to program it. So at the time, I didn't feel like to go and buy a package where you need to spend 1,500 or $2,000 to get that package so I could get the code. So I go to the dealer and I say, look, I have one of your car. We have the ECU. I buy the ECU from your parts place, but I need you to program it or give me the security code. They say, no, we're not working on it and we're not giving you the security code. So I asked to speak to the manager and he repeat the same thing. So at that point, I have to put my foot down. Hey, you responsible for this car in the market. And if I take you to court, I'm going to win you because you is the dealer And if you're not going to fix it, then you have to give me the information. So they back down and give me the code. So nothing changed in terms of the market that the dealership want to corner the market for themselves. What changes how we approach that in today? And this is where I say you have to build a network. If each technician just look as themselves as the I am, and because I use the I am, I don't have to share nothing, then you're in trouble.
In trouble, yeah.
Because guess what? The technician in the dealer, he have information that we don't have, and we have information where him don't have. So the two have to work together, and you get around that part easy.
And we have the ability these days to do that because we have networks like EV Jamaica, social media, all them things that make network easy.
Yes. And it's important again, because it easily overlook. Like, I want to know about fixing this car and nobody else know about it. So I get all of the work done with to fix this car. You see? And that make you can't help. And remember again too, remember, um, technicians is one word, but technician breakdown in demographic and different thing. So you will find certain type of technician lock the data, but some type of technician don't lock it, whether them working at the dealer or not. Them have full access. So it's important to build a network and don't focus just on self. And that is the biggest part to overcome that hurdle.
All right. I think this is a good ending segment because we covered everything else. Gentlemen, I thank you so much. Kevin, I thank you very much for being here and sharing your knowledge and expertise in relation to the repair of your vehicle, as well as giving some very good insight on the industry itself. Um, to all, this video has been recorded, so it's going to be shared up. It's going to be shared on the Plugin Jamaica YouTube channel, as well as Kevin's own YouTube channel as well. So
Yes.
if you want to reach out to Kevin, Kevin is in the EV Jamaica group. He is open to answering any questions that don't cost him any money, but he will help you. So I thank you all for being here and enjoy the rest of your day.
Thank you, everyone, also.
All
Thank you.
right.
It was great. It was a great presentation.
Yeah,
Thank
respect.
you. I appreciate it.